The theory of plate tectonics. The theory of plate tectonics, rolled up in a nutshell, is that the Earth's crust is broken into 7 chunks, and these chunks are moving due to convection, which is what we will learn about later on. Here's a picture of the 7 plates. There are 2 types of plates, oceanic and continental. With continental plates have land on them. With oceanic plates which have oceans on them. They happen to be more dense than continental plates. Within these plates we have plate boundaries. We have 3 types of plate boundaries: divergent boundaries, transform boundaries, and convergent boundaries. With divergent boundaries, plates are spreading apart due to magma pushing to the surface. With transform boundaries, it's 2 plates being pushed together and rubbing against each other, slipping against each other. Convergent boundaries are 2 plates being forced together. Okay, now we have convergent boundaries. Now with convergent boundaries, what's going to happen is plates are going to be crashing into each other. So watch these plates right here. They come together and boom. Now what's going to occur is you can have mountains just like this. It's a little bit of a crappy drawing, but don't dwell on it. So this is continental and continental. When continental plates collide, it forms mountains, right? A place where this has happened is the Indian Himalayas. They were crashing together with the Eurasian plate and forming mountains. Now, let's say we have 2 oceanic plates crashing together. Now, with 2 oceanic plates crashing together, you can have all kinds of crazy stuff. Not just earthquakes like with two continental plates. With this, you can have tsunamis, earthquakes, chain of volcanic islands, volcanoes, mountains, tons. A place where this is happening is the Aleutian Islands in Alaska. So now imagine we have continental with oceanic. So when you have continental with oceanic, the oceanic plate is more dense, so it's going to slip underneath of the continental as they collide. Now, what's going to happen is subduction of the oceanic plate. Mountains and volcanoes are going to form. Earthquakes and tsunamis can occur from this very often. This is happening with the North American plate and the Antarctic plate. It's in Mexico. A transform boundary is when 2 plates come together and they slip on one another. And when they slip, earthquakes occur. Now, an example of this would be the San Andreas Fault in California. Faults can occur anywhere that there's a transform boundary, but this is one of the most popular. It's happening in California. Now, with this, I have to talk about continental and oceanic plates, right? But with transform boundaries, it is very uncommon to find oceanic plates with a transform boundary. It is possible, but not very likely. So both of these are continental plates. Next we have a divergent boundary. Divergent boundaries occur when magma is being pushed up to the surface to spread plates apart. Now what happens is the magma starts coming up, and it starts pushing the plates apart just like this, and they go apart. Now, with continental divergent boundaries, you can have rift valleys, which are rift valleys, and with oceanic, you can have ridges. Now, the most popular ridge is the Mid-Atlantic Ridge. This thing right here, this is the Mid-Atlantic Ridge. The divergent boundary is between the South American plate and the African plate, as you can see right here in this area right here. Here we have convection current, which is what I talked about earlier. Now, here's the Earth right here. On the outermost, we have the Earth's crust. You can see that in blue. And then we have the lithosphere, followed by the asthenosphere, and then this little blue blob right here is the Earth's core, which is believed to be entirely iron. Now, there's magma within the Earth's core, and so it goes. Now, we're going to be talking about the convection current. Convection current is when the magma gets hot, it rises up to the Earth's surface, It cools down when it gets here, and then it comes back down just like this. So, if you watch the arrow, here's how it's going to go. It's going to go up. Every time it goes up, it cools off, and then when it comes down, it heats right back up. This is how all the boundaries are occurring, like a divergent boundary. When magma pushes up through the surface to push plates apart, it's because of convection current. Okay, so imagine this arrow right here. Imagine this is the magma. It's going to push up. And imagine these two plates right here. These are going to be the divergent boundary. The magma is going to push them up, and they're going to spread apart just like this. Now, with a convergent boundary is when magma is pushing on either side over here and pushing them together, okay? So what's going to happen is they're going to come together and form mountains, as I spoke about earlier. Elaboration. There are a few more things you need to know. The lithosphere is the uppermost level of the Earth's crust. Underneath that is the asthenosphere. Lithosphere. The lithosphere is made up of rigid rocks, meaning they can bend but can't flow. The asthenosphere. Rocks in the asthenosphere are made of basically plastic, meaning they can flow in response to deformation. At the heart of all this is the Earth's core, which is believed to be iron. So that is how convection occurs. It heats the magma, and as seen in the previous slide, the convection current just flows and flows and flows.